In 1989, a researcher named David Strahan noticed something that didn't make sense. Children raised on farms, surrounded by dirt, animals, and fermented food, had dramatically lower rates of allergies, asthma, and autoimmune disease than city children raised in clean environments. He called it the Hygiene Hypothesis. What he was really describing was a gut microbiome that had never been trained. Your immune system doesn't just live in your bloodstream. 70% of it lives in your gut wall, and it learns from what you feed it. For most of human history, people were accidentally feeding it exactly what it needed, without knowing why. Then refrigeration arrived, and we stopped fermenting everything. In the last 40 years, rates of IBS, autoimmune disease, anxiety, and metabolic dysfunction have all climbed in parallel with the collapse of fermented food in the Western diet. That's not a coincidence. That's a mechanism. 15 fermented foods, 15 ways to feed it right. And one of them, number 7, has a single enzyme in it that does something no pharmaceutical has managed to replicate cleanly. That one alone is worth staying for. Sauerkraut. Plain, simple, fermented cabbage. 2 ingredients, cabbage and salt. No vinegar in the traditional version. That distinction matters more than most people realize. Vinegar-pickled cabbage is dead. The bacteria have been killed. You're eating texture, not biology. True lacto-fermented sauerkraut is very much alive when it reaches your gut. Inside a properly fermented jar, you'll find predominantly Lactobacillus plantarum and Lactobacillus brevis. Think of them as the cleanup crew for your gut lining. They compete directly with the opportunistic bacteria that drive bloating, irregularity, and systemic inflammation. Here's the counterintuitive part. The cabbage itself, before fermentation, contains compounds called glucosinolates. Fermentation by these bacteria converts those glucosinolates into isothiocyanates. Those are the same anti-inflammatory compounds found in broccoli sprouts. Fermentation doesn't just preserve the cabbage, it upgrades it. Studies examining fermented versus unfermented brassica consumption suggest the fermented form shows notably higher bioavailability for these protective compounds. Evidence points toward a meaningful upregulation of the body's own antioxidant defenses, the NRF2 pathway, from regular sauerkraut consumption. Making your own sauerkraut takes about 15 minutes of active work. The rest is waiting. You need 1 medium head of green cabbage, roughly 2% of its weight in non-iodized salt. Iodine kills the lactobacillus, and a clean, wide-mouthed jar. Shred the cabbage thin, about 2 millimeters. A mandolin works. A sharp knife works just as well. Add your salt, then squeeze and massage for about 5 minutes. You are breaking the cell walls. The cabbage will weep its own liquid. That liquid becomes your brine. Pack it tightly into your jar. The cabbage must stay submerged under the brine. Use a smaller jar as a weight inside the opening if needed. Cover with a cloth, not a sealed lid, to let carbon dioxide escape. Leave it at room temperature for 5 to 7 days. Taste after day 3. When it's pleasantly sour and slightly fizzy on the tongue, it's ready. Move it to the fridge. 1 to 2 tablespoons with meals, 3 to 4 times a week, is a practical maintenance dose. Kimchi is sauerkraut's more complex cousin, and it outperforms it on several specific measures. The fermentation here involves a richer microbial community, Lactobacillus kimchi, Leuconostochmus centauroides, Weissella corensis. A 2021 study published in Cell examined gut microbiome diversity in participants consuming high-fermented food diets. Kimchi was among the primary sources. Results indicated measurably increased microbiome diversity and a reduction in inflammatory protein markers, including IL-6. Kimchi also delivers capsaicin from the chili, the compound that blocks the same internal fire signaling molecule, substance P, that pain medications target. It's not mild, it's measurable. There's something else in kimchi that doesn't get enough attention. The allicin from the garlic. Allicin is what gives garlic its heat on the tongue, but functionally it acts like a natural broad-spectrum disruptor for harmful gut bacteria, without meaningfully touching the beneficial strains. It's selective. Traditional kimchi is a commitment, but a simplified version, what Koreans call mak kimchi or easy kimchi, takes 30 minutes. Napa cabbage, coarse salt, gochugaru chili flakes, garlic, ginger, fish sauce or soy sauce if you prefer it vegan, and a small amount of rice flour paste to help the mixture cling. Salt the cabbage for 2 hours. Rinse well. This draws out excess water and softens the cell walls so the paste can penetrate. Then mix your paste, garlic, ginger, gochugaru, fish sauce, and a tablespoon of the cooked rice flour paste. Coat every leaf. Pack into a jar. Leave at room temperature for 1 to 2 days. Then refrigerate. Kimchi improves over weeks in the fridge. A 2 to 3 tablespoon serving with your main meal is a practical target. Kefir contains more probiotic strains in a single glass than most probiotic supplements carry in an entire bottle. That is not marketing language. Analyses of traditionally prepared kefir consistently identify 30 to 50 distinct microbial strains, bacteria and yeasts working together. Among those strains, Lactobacillus acidophilus, Bifidobacterium bifidum, and Saccharomyces cerevisiae, a beneficial yeast that helps crowd out Candida species. Studies suggest regular kefir consumption over 8 weeks correlates with measurable shifts in gut microbiome composition and reductions in fasting blood sugar markers in pre-diabetic populations. Kefir also contains kefiron, a polysaccharide produced specifically by Lactobacillus kefiranophaciens. Think of kefiron as a coating agent for your gut lining. Preliminary observations suggest it reduces gut permeability, the condition sometimes called leaky gut, by reinforcing the tight junctions between intestinal cells. Home kefir making is the most forgiving fermentation there is. You need kefir grains, a one-time purchase, or free from any local kefir making group, and whole milk. That's it. Add 1 to 2 tablespoons of grains per cup of milk. Cover with cloth. Leave at room temperature between 68 and 77 degrees Fahrenheit for 24 hours. When it's thickened and smells pleasantly sour, strain out the grains, refrigerate the kefir, and start the next batch immediately. 1 cup per day is sufficient. Drink it plain, blend it into smoothies, or use it in place of buttermilk in any baking. The live cultures survive mild cooking but are largely destroyed above 115 degrees Fahrenheit, so add it cold to dishes where you want the probiotic benefit intact. Kombucha gets dismissed in some circles as a trend. The fermentation science behind it is not new. The earliest reliable documented records of kombucha come from Russia and Eastern Europe in the late 1800s. Though fermented tea traditions in East Asia predate those records by an unknown period, the Qin dynasty origin story that circulates widely online has no verified historical basis. The SCOBY, symbiotic culture of bacteria and yeast, produces organic acids during fermentation: acetic acid, gluconic acid, and glucuronic acid. Glucuronic acid is the one that warrants attention. It's a conjugation agent, meaning it binds to toxins and metabolic waste products in the liver and facilitates their excretion. Your liver produces it naturally. Kombucha provides a dietary source. Kombucha also contains B vitamins, B1 and B6, produced reliably during fermentation. B12 has been detected in some preparations, but its presence is strain-dependent and inconsistent. Kombucha is not a reliable B12 source. More consistently, kombucha carries a small but meaningful amount of catechins inherited from the tea base. Those catechins help modulate the NF-κB signaling pathway, the body's master switch for chronic low-grade inflammation. Brewing your own kombucha costs roughly 30 cents a bottle once you have your SCOBY. You need black or green tea, sugar, filtered water, a SCOBY, and starter liquid from a previous batch or from a raw store-bought kombucha. Brew 1 liter of strong tea, dissolve 1/4 cup of sugar per liter while still hot. Cool completely. This step matters. Heat kills your SCOBY. Then combine with your starter liquid and SCOBY in a wide-mouth glass vessel. Cover with cloth. Ferment at room temperature for 7 to 10 days. Taste after day 7. When it's pleasantly tart with a slight fizz, bottle it. 4 to 8 ounces per day is a practical dose. More than that, and the acidity can irritate sensitive digestive systems. Miso is fermented soybean paste. What differentiates it biochemically from tofu or edamame is what Aspergillus oryzae, the fermentation mold called koji, does to the soy protein over months of aging. Koji breaks long soy proteins into short peptides and free amino acids. This makes miso exceptionally bioavailable. The body absorbs its protein with less digestive work than almost any other plant protein source. One of those peptides, a compound called GABA, gamma-aminobutyric acid, is the same neurotransmitter that anti-anxiety medications like benzodiazepines act on. Miso provides a dietary precursor that's worth stating plainly. Epidemiological data from Japan, where miso consumption has been tracked for decades, suggest a correlation between regular miso soup consumption and lower rates of gastric cancer, even when sodium intake is controlled for. Evidence indicates the fermentation byproducts, particularly isoflavone aglycones, may have a protective effect on gastric mucosa. You do not need to make your own miso. Unlike sauerkraut or kefir, traditional miso requires months to years of aging. Buying it is fine, but buy unpasteurized. The pasteurized versions sold in most supermarkets have been heat-treated, killing the live cultures. Look for unpasteurized, or nama, on the label of a Japanese brand miso from a refrigerated section. The cardinal rule with miso: never boil it. Add it to soup after the heat is off, or stir it into warm, not hot, water. Boiling destroys both the probiotic organisms and the heat-sensitive enzymes that drive its digestive benefits. 1 tablespoon dissolved in hot water with a strip of dried kombu seaweed is a complete therapeutic broth. Tempeh is made from whole soybeans bound together by Rhizopus oligosporus, a mold that forms a dense white mycelial mat. What you're eating, essentially, is a soybean cake held together by fungal threads. That fungal fermentation does something to soy that no other processing method achieves. It neutralizes phytic acid. Phytic acid is the compound in legumes and grains that binds to minerals, zinc, iron, magnesium, and carries them out of the body unabsorbed. Think of phytic acid as a mineral thief. Fermentation disarms it. Tempeh delivers the protein and minerals of soy with dramatically improved absorption. Tempeh also delivers a more complete amino acid profile than most plant proteins, and its fermentation-enhanced isoflavone bioavailability is worth noting. The isoflavone aglycones, genistein and didzine in their transformed fermented form, are absorbed at significantly higher rates than the isoflavones in unfermented soy. Evidence suggests these compounds have mild estrogen-modulating and anti-inflammatory properties. One note on K2, tempeh is fermented by a fungus, not by bacillus bacteria, and U.S. nutrient databases report no measurable K2 in standard tempeh. That K2 claim you sometimes see attached to tempeh belongs to Natto, which we'll get to shortly. Tempeh can be made at home but requires a starter culture and careful temperature control. For most people, store-bought is practical. Unlike miso, tempeh is pasteurized by cooking, so you are not getting live probiotics from it. You are getting the prebiotic compounds, the transformed proteins, and the enhanced mineral bioavailability. All of that survives cooking. Slice tempeh thin and pan-fry in a small amount of coconut oil with tamari and ginger until each side is deeply golden. The Maillard browning adds flavor, and the moderate heat does not meaningfully degrade the fermentation-transformed proteins or isoflavone compounds. Both survive cooking well. 3 ounces, 3 times a week, is a practical amount for a consistent contribution to plant protein intake and fermentation-enhanced isoflavone delivery. Natto is the most challenging food on this list for Western palates. The smell is aggressive. The texture, sticky, stringy, is unfamiliar. If you can get past both, the evidence behind it is arguably the most compelling of anything I'll discuss today. Natto is fermented by Bacillus subtilis var. Natto. That bacteria produces nattokinase, an enzyme that directly breaks down fibrin, the protein mesh that forms blood clots. Multiple clinical studies suggest natto supplementation reduces blood clot formation markers and may support healthy blood pressure in the normal range. Natto delivers this enzyme in food form, and the K2 content. Natto contains the highest dietary concentration of vitamin K2 MK7 of any food measured. A single 100-gram serving, roughly the size of a standard commercial container, provides somewhere between 800 and 1,000 micrograms of MK7. Current adequate intake guidelines for total vitamin K sit at 90 micrograms per day for women and 120 for men, with no separate official figure yet established specifically for MK7. Natto exceeds any reasonable daily target by a wide margin, which also means people on anticoagulant medications like warfarin must check with their physician before eating it regularly. The traditional method? Eat it cold, directly from the container. Add a small amount of Japanese mustard, a drizzle of soy sauce, and stir aggressively. The stirring develops the sticky filaments and is considered essential to texture. Eat it over warm rice or toast. Do not heat natto above 104 degrees Fahrenheit. That degrades the nattokinase enzyme. If the flavor is prohibitive, and for many it is, nattokinase is available in encapsulated supplement form, standardized to its enzyme activity, but eating the whole food provides the K2, the bacillus probiotic, the complete amino acid profile, and additional fermentation byproducts that isolated supplements do not replicate. Water kefir is the dairy-free alternative to milk kefir and is fermented by a different set of grains, primarily Lactobacillus hilgardi and various bifidobacterium species, alongside the yeast Saccharomyces cerevisiae. What makes water kefir strategically useful is its versatility. It ferments sugar water, coconut water, fruit juice. For anyone who cannot tolerate dairy, it delivers a comparable diversity of lactic acid bacteria strains in a format the gut absorbs rapidly. Preliminary observations suggest water kefir's lactobacillus strains modulate the immune response at the gut-associated lymphoid tissue level, the immune tissue that lines roughly 70% of the body's total immune surface. 3 tablespoons of water kefir grains, 1/4 cup of cane sugar dissolved in 4 cups of filtered water. Add 2 tablespoons of unsulfured molasses for mineral content. Molasses feeds the grains. Add a slice of dried fig for the wild yeasts it carries. Cover with cloth, ferment 24 to 48 hours. Strain, bottle, refrigerate. Second ferment option, bottle the strained kefir with a tablespoon of fruit juice or a few berries, seal, and leave at room temperature for 12 hours. This builds carbonation. The result is a naturally fizzy, probiotic-rich drink that costs pennies. Beet kvass is almost entirely absent from Western fermentation culture, which is unfortunate because its primary active compounds are unusual enough to merit specific attention. Fermented beets produce and concentrate betalains, the pigments responsible for the deep crimson color. Betalains are both antioxidant and anti-inflammatory, but they also act as nitric oxide precursors. In practical terms, they dilate blood vessels by signaling the vessel lining to relax. This is the same mechanism targeted by certain blood pressure medications. Evidence from beet juice studies, unfermented it must be said, demonstrates measurable reductions in systolic pressure within 2 to 3 hours of a single dose. Fermentation concentrates these compounds. Beet kvass also delivers the prebiotic fiber from the beet itself, now transformed into short-chain fatty acids by fermentation. Butyrate, the primary short-chain fatty acid produced, is the preferred fuel source for colonocyte cells, the cells that line your colon. When colonocytes are well-fueled, gut barrier integrity holds. When they're not, permeability increases. 3 medium beets, scrubbed but unpeeled, the skin carries the wild lactobacteria. Cut into rough cubes, pack into a quart jar, add 1 teaspoon of non-iodized salt, fill with filtered water. Cover with cloth. Ferment 3 to 5 days at room temperature until the brine is deeply colored and tastes pleasantly sour. 4 ounces, half a cup, Before meals is the traditional Slavic dose. It's not a beverage you chug. It's a digestive tonic. The salty sour flavor is acquired but surprisingly pleasant once your palate adjusts. Yogurt is the most familiar item on this list and the most misunderstood. Most commercial yogurt, the fruit-flavored kind in plastic tubs, contains more sugar per serving than a can of soda. The probiotics, if present at all, are often insufficient in count to survive gastric acid transit. Traditionally made yogurt, whole milk, 2 strains, 24-hour fermentation, is a different product. The extended fermentation time allows Lactobacillus bulgaricus and Streptococcus thermophilus to reduce the lactose content by up to 40%. This is why many people with lactose sensitivity tolerate traditionally fermented yogurt, but not fresh milk. The fermentation has already done the digestive work. Clinical trials examining 24-hour fermented yogurt, specifically the SCD protocol yogurt fermented to near zero lactose, suggest significantly improved tolerability in IBS populations and measurable increases in bifidobacterium counts after 2 weeks of daily consumption. Heat 1 liter of whole milk to 180 degrees Fahrenheit. This denatures the whey proteins and gives a firmer set. Cool to 110 degrees. Stir in 2 tablespoons of a plain yogurt with live cultures as your starter. Pour into a clean glass jar. Incubate at 100 to 110 degrees for 24 hours. Incubation options: a yogurt maker, an instant pot on the yogurt setting, a dehydrator set to 105 degrees, or the simplest method, a preheated and then turned off oven with just the oven light on overnight. The light generates just enough heat. After 24 hours, refrigerate without stirring for at least 2 hours before serving. The result is thick, tangy, and virtually lactose-free. 1 cup per day is sufficient for microbiome maintenance. Fermented hot sauce is perhaps the most accessible gateway into home fermentation because most people already use hot sauce daily. The difference between commercial vinegar-based hot sauces and a lacto-fermented version is the same difference we noted with sauerkraut. One is a condiment, the other is a living food. Capsaicin, the primary bioactive in chili peppers, acts on the TRPV1 receptor, the same receptor that detects actual heat. Repeated activation of TRPV1 in the gut desensitizes it, which is one proposed mechanism behind the correlation between regular chili consumption and reduced visceral hypersensitivity in IBS research. Additionally, capsaicin has demonstrated AMPK activation in multiple in vitro studies. AMPK is the metabolic sensor that drives fat oxidation and improves sugar handling. Blend half a pound of fresh red chilies, stems removed, with 3 garlic cloves and 1 teaspoon of non-iodized salt per cup of mash weight. Pack into a jar, press down firmly to submerge under its own liquid, cover with cloth, ferment 3 to 5 days at room temperature. Blend again after fermentation. Strain, bottle. A half teaspoon daily on eggs in soups over grains delivers therapeutic capsaicin levels with the added benefit of the live cultures produced during fermentation. If you build heat tolerance gradually, the gut benefits accumulate. Fermented garlic honey is the most counterintuitive ferment on this list. Honey is antimicrobial. It kills bacteria through its low water activity and hydrogen peroxide content. So, how does fermentation occur? The moisture released from the fresh garlic dilutes the honey locally, dropping the water activity enough to allow the wild yeasts and lactobacilli present on the garlic's skin to begin fermentation. Over the first week, the honey liquefies and begins to bubble. By week 4, the olechin from the garlic has undergone enzymatic transformation, converting to alum-mercaptan and other sulfur compounds that are more bioavailable and have demonstrated direct antiviral and antibacterial activity in cell culture studies. The honey simultaneously concentrates these compounds. Peel a full head of garlic. Do not crush or chop. Place whole cloves in a small jar. Cover completely with raw, unpasteurized honey. Lid loosely, not sealed, as CO2 must escape. Tip the jar daily to keep all cloves coated. Fermentation begins in 3 to 7 days. Most active period is weeks 1 through 4. Ready to use after 4 weeks. Improves for up to a year. 1 to 2 cloves daily, along with a half teaspoon of the honey during cold and flu season. The transformed allicin compounds, the concentrated honey polyphenols, and the developing probiotic culture create what ethnopharmacological tradition across Europe and Asia has documented as a robust immune tonic. Evidence from clinical trials on garlic supplementation suggests meaningful reductions in cold frequency and duration with regular use. Lacto-fermented oats are the oldest grain preparation method documented in Northern European food traditions. The Norse called it soured porridge. The functional reason for souring grains wasn't flavor, it was survival. Oats contain phytic acid, the same mineral-binding compound we discussed with tempeh, and also contain avenin, a protein that can provoke gut inflammation in sensitive individuals. A 12 to 24-hour soak in slightly acidified water activates phytase enzymes present in the grain, breaking down up to 60% of the phytic acid. It also begins the partial breakdown of avenin. The result is a grain that delivers more iron, zinc, and magnesium per serving than the same oats eaten without soaking. The night before, combine 1 cup of rolled oats with 1 cup of warm filtered water and 1 tablespoon of whey, plain yogurt, or apple cider vinegar. The acid inoculates the soak and initiates enzymatic activity. Cover. Leave at room temperature overnight. In the morning, drain, rinse briefly, cook as usual. The texture changes. Fermented oats cook faster and develop a slightly deeper, more complex flavor. The mineral content of your bowl has meaningfully increased. This takes 30 seconds of additional effort the night before. That's the entire intervention. Tepache is a traditional Mexican fermented pineapple drink. It ferments the rind and core, the parts most people discard, in water with a small amount of brown sugar and spice for 2 to 3 days. Pineapple rind carries bromelain, a proteolytic enzyme complex that breaks down protein bonds. It's the reason raw pineapple makes the tongue feel raw. It's digesting the protein on your tongue's surface. Fermentation partially converts and concentrates bromelain, and the resulting liquid carries both the enzyme and the probiotic organisms that colonize during fermentation. Studies on bromelain indicate anti-inflammatory activity via inhibition of prostaglandin synthesis, the same general target as nonsteroidal anti-inflammatory drugs, though at lower intensity. Rind and core from 1 pineapple, washed. 2 tablespoons of brown sugar per liter of filtered water, dissolved. 1 cinnamon stick, 3 whole cloves. Combine in a glass jar. Cover with cloth. Ferment at room temperature 2 to 3 days. Strain. Refrigerate. 8 ounces per day. Tepache sits somewhere between a fermented drink and a digestive tonic. It's lightly fizzy, pleasantly tropical, and gently sweet. It is, essentially, a use for waste. The fermentation takes a pineapple's discarded parts and transforms them into something more biochemically active than the fruit flesh itself. Raw, unfiltered apple cider vinegar, specifically the kind with the mother intact, occupies an interesting position. It is one of the most widely used folk remedies in Western herbalism and one of the most poorly understood. The marketing vastly overreaches the evidence. So let me tell you what the evidence actually says. Acetic acid, the primary compound in all vinegars, has been demonstrated across multiple controlled trials to blunt the post-meal blood sugar spike when consumed before or with high-carbohydrate meals. The mechanism: acetic acid slows gastric emptying, reducing the rate at which glucose enters the bloodstream. Studies suggest reductions in post-meal blood sugar in the range of 10 to 20% with 1 to 2 tablespoons before carbohydrate-containing meals. Some smaller trials have reported higher figures, but the most reliable meta-analysis data clusters in that 10 to 20% range. The mother, the cellulose mat formed by Acetobacter bacteria, contains the live bacterial culture. the enzymes produced during fermentation, and a concentration of polyphenols from the apple. It is the mother, not the acetic acid, that provides the probiotic component. Filtered pasteurized vinegar contains none of it. 1 to 2 tablespoons in a large glass of water, 15 minutes before your largest carbohydrate meal. That's it. Do not drink it undiluted. The acidity at full concentration can erode tooth enamel and irritate the esophagus. Diluted, it's well tolerated. And always shake the bottle before using. You want the mother distributed through the dose, not settled at the bottom. The mother is not a sign of poor quality. It is the quality. 15 foods, no supplements required, no prescriptions, no lab coat, just the accumulated knowledge of roughly 10,000 years of human food preservation, now confirmed, item by item, by peer-reviewed research. I want to be clear about something. This is not alternative medicine. Fermentation is not a fringe idea. It is how food was stored before refrigeration, and in doing so, it happened to produce some of the most biochemically dense, microbiome-supportive foods humans have ever consumed. We stopped eating them, and the data on gut health, metabolic function, and immune regulation declined in parallel. You do not need to make all 15. Start with one, the one that sounds most manageable. Sauerkraut for most people, 2 ingredients, 15 minutes, 1 week. Then add a second. If this video reached you at the right moment, if something here clicked into place, the subscribe button is directly below. I post every week. No supplements to sell, no affiliate links, just this. Here's what I want to know from you. Which of these 15 have you already been making? And for those of you who haven't started, what's actually been stopping you? I read every comment. Leave it below.